In our last class, we already established that if we have a function y, which is a function of x, so the gradient of the function dy dx can be written as f bar of x. These are called derivative or the gradient differentiation. And if we do the reverse, from here we can say dy equals to f prime of x dx. So if you integrate dy, which also the integral of what? The other side. So this equals y, and that becomes what? Our f of x. But anytime we integrate, we add c to it. Sorry, we have our function plus c. And we've already dealt with everything under integration of polynomial, excluding whenever we have multiplication or function of a function involving, But for a general polynomial, if dy dx equals to ax raised power n, then our y equals to a into what? Raised power n plus 1 divided by n plus 1 plus c. Meaning we add 1 to the power, then we divide by the new power. So that's how to go from differentiation to integration. Or that's how to go from gradient to the function. And we did some application. So we did application of rate of change. And also we established that we can use calculus to look for the area under what? The graph of a function. And the area is the integral of that function with respect to x. And we said if there is a rotation about a certain axis, the volume of a particular function can be gotten by integrating the area along a particular path. That will be area dx. So which can either be, by, whenever there is a rotation, it will give us circumference of a circle. So pi y squared dy or pi s squared dx, or the integral of pi z squared z, depending on the function of what function is the area. So if the area is a function of x, it will be dx. If it's y, dy, it's x dx. We've solved question on this. So the next thing is to look into the integration of other functions. The integration of other functions. But before that, we'll look into function of a function. Under differentiation, we look into quotient rule, product rule, function of a function, then implicit function. So under integration, there is no direct rule for quotient rule and for product rule. So what we have is function of a function. In case we now have division of two functions or the product of two functions, there are ways we can manipulate. So we can use what we call trigonometric substitution where necessary for when you have for quotient division of two functions. And we can have what we call integration by parts also. But for this class, let's focus on function of a function first. Now, suppose we have a function like this. Let's say dy dx equals to 2x r cubed. You can tell me this, that y equals to, what are you going to do? 2x cubed plus 1 over 3 plus 1 plus c. So it means y equals to 2x raised to power 4 over 4 plus c. So y equals to half x raised to power 4 plus c. The integration of polynomial, or this of a monomial. So suppose dy dx equals to 2x plus 1 r cubed. Now in this case, let's suppose, okay, you might think you want to expand, but to expand it should be a bit long, so you don't need to expand this. So what are we going to do? We can let let u equals to 2x plus 1. From here it means dy dx equals to u cube. So from here we can say dy equals to u cube dx. So by wondering, oh, let's integrate both sides. So y equals to integral of u cube dx. But the problem is we cannot integrate u with respect to x. We can only integrate x with respect to x or u with respect to u. So what must be here should be du, not dx. So you have to go and look for du. You will now come here. From here we can look for du dx. From here du dx, you have to differentiate. It becomes what? 2. From here it means du equals to 2 dx. Our aim is to replace the x. From here it means dx divided by 2 over 2 over 2. So it means the x equals to du over 2. You now come here and say this y equals to integral of u cube. Then what's the x? Du over 2, which is written as half of u. So we can also write this one. It implies that y equals to half of u cube du. Why? I can put this 2 under this. I can also write as u cube over 2 du. Then over 2 same thing as half. You can bring the half out as a constant. So from here it means y we can now what? Integrate. So add on to the power, divide by a new power. That would be what? U by 4 divided by what? 4 plus c. So from here our y equals to 2 times 4, 8. What's our u itself? U is 2x plus 1. So that would be what? 2x plus 1 over 4 all divided by 2 times 4, 8 plus c. So this is like a function of a function, although it's different from that of differentiation. Now if you have something like this in integration, if it is differentiation, the shortcut is you differentiate the whole. We bring this 3 to the back here, remove 1 from it. They will now multiply by differential of what you have inside. In integration, what's the shortcut? We add 1 to the power, that's 4. You add a new power, 4. We now divide by the differential of what you have inside. So if you differentiate 2x plus 1, that is 2. It means you integrate in general. I assume this is just ordinary x. You add 1 here, it becomes 4. Divide by 4. So if you do that, you get this. Then you now multiply, so you now divide by the differential of what you have inside. So if you differentiate 2x plus 1, the answer is 2. After you integrate in general, you now divide by the differential of what you have inside. So that is, if you have this kind of question. Let's take another example on this so that you get it better. In that example, we'll solve it normally in this way by using substitution. Then also, we are going to use the shortcut. Suppose we are told to integrate this. So what are we going to do? We can, according to the method we just explained, we can let what you have here because you cannot expand this. It's very difficult. It's more complicated if you expand. So solution, we can let u to be equals to s squared minus 1. After writing this one, you can always get du dx. From here, it means du dx equals to differentiate 2x. So let's move on. You see something now? You see something now? I'll change this example. Let's continue first. Then come back here and write the integral of what? S squared minus 1 becomes u. U raised to power half, then dx. But I said we cannot integrate u with respect to x. You have to replace one with the u. And from here, if you make the u the subject, sorry, the x the subject, the x becomes, you can switch du over 2x. So this becomes the integral of u raised to power half. What's now the x? Du over 2x. Now we think that, oh wow, we are done, we can continue. But there's a problem. We are having u with respect to u, and we're having 2x, and x is a variable. I think x is a constant, we can just continue. We cannot continue because of this x. Everything here must be u. So what can we do? It's either I come back here and make x the subject. But doing that, it will be more complicated. Let's come here and make x the subject. From here, it implies that s squared equals to u plus 1. Then it means s equals to square root of what? U plus 1. Now come and write what? U raised to power half du over 2, what is now x? Square root of what? U plus 1. It's getting more complicated. So it means for this particular one, we cannot use this approach. And that is what makes the integration to be, much difficult than differentiation. So we have to use substitution. Sometimes you have to use trig substitution. So now let's reduce this problem for JAMB standard. Okay, let us consider this. Same approach, you can say let u to be equals to 3x plus 1. From here, it means du dx equals to 3. And from here, dx equals to du over 3. We'll come and replace as integral of u raised to power half. What's now the x? Du over 3. Then this 3 is a constant, we can bring it out, and this becomes 1 over 3 integral of what? U raised to power half du. Aha, we can now integrate. How do we integrate? We add 1 to the power, divide by a new power. So initially we have half there, so this becomes u raised to power half plus 1 divided by what? Half plus 1 plus c. And this becomes 1 over 3 times u raised to power 3 over 2 over 3 over 2. So these 2 can go up, and this turns to 2. 3 times 3, 9, u raised to power 3 over 2 plus c. And the answer becomes 2 over 9. What is now u? 3x plus 1. 3x plus 1, all raised to power 3 over 2 plus c. And that's the answer for the integral of 3x plus 1, all raised to power half with respect to x. Now, the shortcuts. What is the shortcut? Just come here straight. From here, we don't need all this process. We just add 1 to half, divided by a new power. So if you add 1 to half, that gives us 3 over 2. So the answer is 3x plus 1. If you add 1 to 1 over 2, it becomes 3 over 2. Then we divide by a new power, which is 3 over 2. Then after that, in this case, we integrate whole. Assuming this is what? Just ordinary x. Then we now divide by... Now, if you differentiate 3x plus 1, it will give us 3. You divide by the what? Differentiation of what you have inside here. Divided by 3 over 1, same thing as what? Times 1 over 3. So this 2 will come up. So we are having this becomes 2 into 3x plus 1 raised to power 3 over 2. This 3 remains, but this 3 multiply this 3, that will give us what? 9. Then plus c. 2 over 9, 3x plus 1 raised to power 3 over 2, same answer. So integrate whole, divide by what? Integral of what you, integrate whole, then divide by what? Differential of what you have inside in shortcut. So with this, in a single line, you can get the answer straight. So that is, if you have this kind of function, when something is having a power and you don't want to expand or you can't expand. So we have this UTME question. We are told to evaluate this. Note, this 2 outside is a constant, so we have no issue with it. So using the shortcut, the answer becomes this 2 remains. We have 2x minus 3 raised to power 2 over 3. So what are you going to do? We add 1 to the power. We divide by a new power, which is what? 2 over 3 plus 1. That's integrate whole. Then we now divide by differential of what you have inside. If you differentiate 2x minus 3, you get 2. So divide by what? 2. And that's the answer. You are done. So the only thing is just to simplify. So this is 2 into 2x minus 3. 3 times 1 plus 2. That's 5 over 2. Divided by 5 over 2 times 1 over 2 plus c. Oh, sorry, 5 over 3. So this 3 will go up. Or in fact, these 2 here can cancel these 2 directly. Then these 3 will go up, so we'll be having 3 into 2x minus 3 raised to power 5 over 3 over 5 plus c. Or you can put this 5 under this 3. That's 3 over 5 into 2x minus 3 raised to power 5 over 3 plus c. That is the final answer. But if the question is a theoretical question, maybe in WAEC, if you do it this way in theory, you don't have a full mark. So to solve, you have to first let 2x minus 3 to be equal to u. Then you continue as you've done earlier. Now let's move to other functions. Okay, suppose here we have dy and we want to get the value of y. Let's start with polynomial function. If you have a x to the power n, we've done that before. Note, for everything we do here, we are adding c to it. So add 1 to the power, divide by new power. So this becomes what? Ax raised to the power n plus 1, divided by what? N plus 1, then plus c. We've done this already. Now, let's now move to trig function. If I have sine x, is going to give us what? Minus cos x. Opposite the law of differentiation. If we differentiate sine, we get cos. If we integrate sine, we get minus cos. So if we have cos x, if we integrate cos x, we get what? Sine x. If we integrate sec square x, we get what? We get tan x. What if we have sine ax? If you have sine ax, if we integrate this function or function, the answer will be minus a cos ax. Right? Not right. This is wrong. We have to integrate the whole. If we integrate the whole, the answer will be what? Minus cos ax. But this time around, we will not multiply, we will divide. So the answer is going to be what? Minus cos ax. Minus cos ax over a. Why over a? Because if we differentiate ax, we get a. So we divide by what? By the differential of ax. Same thing goes here. If we have cos ax instead, the answer will be sine ax over a. What about sec square ax? The answer will be sine ax over a. These are for the basic trig function. Now let's move to exponential function. If we have e raised to power x and we integrate, the answer remains e raised to power x. Okay, what if we have e raised to power ax? What will be the answer? E raised to power ax, but this time around divided by a. Now let's move to logarithmic function. If you can recall, anytime we differentiate ln x, the answer is 1 over x. So meaning if we integrate 1 over x, we are going to get what? In x. Okay, what if we have, still under this one, 1 over x plus 1. If we integrate, what will be the answer? The answer is ln x plus 1. Oh, you might be wondering, okay, why can't we divide by the dimension of the inside? If we differentiate x plus 1, the answer is 1. So divided by 1 is still what? Oh, we have there. But what if we now have, let's say, 1 over 2x? What if we have 1 over 2x? You don't need to memorize this, you can solve it out with the idea here. We know 1 over 2x can be written as 1 over 2 times 1 over x. So if you integrate this, half is constant, so you can just bring out the half. That's half into what? 1 over x. So just bring out the half, then we integrate 1 over x, so the answer will be what? Half in x. plus c. Okay, note all this, then let's solve questions. So this is the question. Evaluate the integral from pi over 12 to pi over 4 of 2 cos 2x. First, this 2 is a constant, so bring it out. If we integrate cos, we get what? Sine. If we integrate cos 2x, we get what? Sine 2x. Then divide by the what? Integral of inside. If we integrate 2x, it's what? 2. Plus c, right? You don't have to put plus c here because we already given the what? The boundary. So just put pi over 12 to pi over 4. And here 2 cancels 2. So impute the upper limit. That will be sine 2. What is the value of x here? Pi over 4. Minus, put the lower limit. Sine 2 to what's x here? Pi over 12. So this is sine 2 in 4 to that pi over 2. Minus sine 2 here is what? 6. That's pi over 6. And we know that pi is 180. So 180 over 2 is 90. So this is sine 90 minus sine 180 over 6 will give us what? 30. Sine 90 is 1. Sine 30 is half. And the answer is minus 1 over 2. As simple as that. 1 over 2. 1997 number 41. Integrate 1 over x plus cos x with respect to x. So what is integral of 1 over x? Ln x. Integral of cos x, sin x plus c. As simple as that. Imagine, jam question for that matter. 1999 number 37. We have to evaluate this. So what is it? If we integrate sine, we get what? Minus cos x. Then minus. If we integrate cos, we get what? Sin x. From where? 0 to pi over 4. We can bring out the minus. That will be minus cos x plus sin x 0 to pi over 4. So let's put the upper limit. That will be cos. First, let's get pi over 4. Pi is 180. So 180 over 4 will give us 45. So that's cos 45 plus sine 45. That's for the upper limit. Then minus cos 0 plus sine 0. Cos 45 is root 2 over 2. Sine 45 is root 2 over 2. Then minus cos 0 is 1. Sine 0 is 0. We've done that under trig, special angles. This plus this give us root 2 minus 1. So the answer is minus root 2 plus 1 or 1 minus root 2. That is the final answer. Okay, consider the following question. Now looking at this, it looks like quotient true. But when you look very well, sometimes you might need to apply trig identity. And I believe you should know that sine square theta plus cos square theta equals to 1. So from here, I can bring this one here. So it means cos square theta minus 1 equals to minus sine square theta. So we can now replace the numerator with what? Minus sine square theta over sine square theta d theta. What happened from here? We have sine square theta over sine theta is 1. So we have what? Minus 1 d theta. Or we can just call it, we can bring the 1 out. Minus 1 d theta. So what's the integral of the theta? The answer is theta. For example, if I ask to integrate 1, I can write 1 with respect to x. I can write this one as what? X is equal to 0. X over 0 is still 1. So I'll add 1 to the power. The divide by all new power, that's x power 1 over 1, which is x. So if you integrate the theta, that's like integrating 1. So the answer is theta. So the answer here is what? Theta from 0 to pi. Oh, there's minus outside. So the answer becomes minus 1. Integral the theta is what? Theta from 0 to pi. So that's just minus theta. So if you put the upper limit, that's minus, upper limit is what? Pi. Minus lower limit is 0. Pi minus 0 is still pi. Then the answer is what? Minus pi. The next question, 2009/40. To me, this is not a question, this is an answer. Why? We've already done this. If you integrate sine square, sec square theta, the answer is what? Straight. The answer is tan theta plus c. Now for this one, we have sec square x minus tan square x. Note, on the table, I didn't give you the integration of tan square theta. It's not there. Although we can get it, but it's not there. So what are you going to do here? We have to still apply trig ratio, trig identities. If you recall, sine square theta plus cos square theta is 1. If we divide through by cos square theta, this becomes what? Tan square theta plus 1 equals to 1 over cos is what? 1 over cos is sec square theta. And if we divide through by sine, we'll be having 1 plus cot square theta equals to cosec square theta. So these are the basic three identity, the three identities you should know. Then this time around we are applying the second one. So since we have no integral for tan square theta, we have to replace it. From here it means tan square theta equals to sec square theta minus 1. So we can come here and say this is the same thing as writing sec square x minus, what is tan square x? That will be what? Sec square x minus 1 dx. Then from here, this is same thing as integral from 0 to pi. Let's expand. Sec square x minus sec square x plus 1 dx. Sec square x cancels sec square x. So we are integrating from 0 to pi. While integrating 1 times dx, we are only integrating the x. Because this will cancel each other. So if we integrate the x, the answer is what? X. From where? 0 to pi. So inside the upper limit, pi, minus lower limit, 0. So the answer, pi. As simple as that. The good news is, for JAMB standard, integration is extremely simple. And they won't ask you beyond this. But if you are to write if you are writing WAEC notes, they are much more complex questions than this. Far more complex. Okay. Now let's do this by ourselves. Suppose you are trying to integrate tan x dx. What will be the answer? I know some of you are so smart. You say, oh, tan is the same thing as sine x over cos x dx. But you cannot see, there is no rule for division. There is no quotient rule here. So what can we do? You can say, let u equals to cos x. Then you now say, from here it means du dx equals to cos x, meaning dx equals to du. Sorry, if you differentiate cos, it gives us minus sine x rather. Minus sine x. So it means dx equals to du over what? Minus sine x. So you can bring the minus up here. So now come here and say this integral of sine x over what is cos x? U. Times what is now dx? Minus du over what? Sine x. So this cancels this. So you can say the answer is integral of minus 1 over u du, which can also write as minus integral of 1 over u du. Oh, what is integral of 1 over u? Ln u plus c. You now say minus ln, what is now u? Cos x plus c. The question is this correct? Yes, the answer is correct. Just that you might not see this directly sometimes. We should know this is a logarithmic function. This minus is same thing as minus 1. And we can bring this minus 1 to the power here. This becomes cos x all raised to power minus 1 plus c. And this becomes ln of 1 over cos x plus c. And what is 1 over cos? 1 over cos x is what? Sec x plus c. So and we know that logarithm of any function must be positive. So we have to take the what? The positive value. So this is the final answer. So in short, anytime we have quotient, a function dividing another function, let's put it this way. If you have integral of, let's say, f of x over g of x dx, if the differential of g of x, meaning if you differentiate g of x, we are not getting f of x, or we are getting a factor of f of x, the best is to substitute, is to do substitution by letting u to be equal to what? G of x. They will solve. That is, if you differentiate the denominator and you are getting maybe exactly the numerator or a factor, whether positive or negative factor of the numerator, we can just let the denominator equal to u. We know that if we differentiate cos, we will get sine, although minus sine. So in that case, we can just let this one equal to what? To u. So we can note this down. We'll take more question on this. Now, all these examples, if you notice, if we differentiate x squared plus 5, we get 2x. So let u equals to x squared plus 5. In this case, du dx equals to 2x, and from there it means dx equals to du over 2x. So this becomes integral of 2x over x squared plus 5 is now u. And what is dx? Dx is du over what? 2x. What happens? 2x cancels 2x. That's what? Integral of 1 over u du, which goes to what? Ln u plus c. And what is u? X squared plus 5. As simple as that. Now next one, if we differentiate 3x plus 1, we get 3. So same way, we can let u to be equal to 3x plus 1. From here, du dx equals to 3. So dx equals to du over 3. So this integral of what? 3 over 3x plus 1 is now u. And what's du? What's dx? Du over 3. So that's what? 1 over u du. So the answer is what? Then u plus c. And what's u? 3x plus 1 plus c. So in short, if we differentiate the numerator and we get exactly the numerator, if we differentiate the denominator and we get exactly what we have in the numerator, the answer is just what? Ln the denominator. So, but if you look at this, if we differentiate x squared plus 1, we get 2x, which is not exactly what we have here. So in this case, there will be what? A factor. So now let's go on before we generalize. Same way, let u equals to x squared plus 1. From here, it means du dx equals to 2x. Then from here, dx equals to du over what? 2x. We come here and write integral of x divided by y times, what's the x? Sorry, u rather. dx is what? Du over 2x. This cancels this. So this becomes integral of what? You can bring 1 over 2 out. Then we have what? 1 over u du. So if you integrate 1 over u, that's what? Ln u plus c. So the answer here becomes what? 1 over 2 ln, what is u? S squared plus 1 plus c. So it means if what we have in the denominator is twice what we have in the numerator, the answer is what? Half of what? Ln denominator. Next question here, this is 3. If we differentiate cos square x, what are we going to get? Before you even differentiate, I think this question is, you don't need to even differentiate. Why? We can use trig identity. 1 minus cos square x is what? Sin square x. Then sin will cancel each other. So at the end of the day, we left it what? Integral of 2 cos x dx. Okay, let's show it out. There might be a mistake here. So this is integral of 2 sin x. 1 minus cos square x is what? Sin square x, which is sin x dx. This take this out. So this becomes what? 2 over what? Sin x dx. How do we do this? So for this, we can say this same thing as 2 integral 1 over sin x dx. If we differentiate sin x, or if we differentiate sin x, we'll be getting cos x, not 1. So 1 is a monomial, why cos x is what? So meaning this method cannot work. So it's either we use trig manipulation, or we use what we call the half angle, identity. So we have some forms of functions that we cannot apply this method directly. So we have to use either trig substitution or using the half angle. So for this class, this is where we are going to stop. In our next class, we'll now take much more complex problem. Then sometimes we can have some cases whereby we can use mathematical method like the trapezoidal rule. So in that case, we are going to use table using what we call trapezoidal rule for approximate method. But we stop it for this class. Next class we'll take much more complex cases. But for the sake of jam, this is all we have.